Alright, well welcome to the session here. We're going to look at the difference between closed loop systems and open loop systems. And I've got two hydraulic rigs here, one on my left, one on my right, and we're going to compare them on the board first, have a demonstration of the open loop, then go back to the board, have a quick look, and have another look at the closed loop. So for a start, the loop we're talking about is the cycle the oil takes through the system. And in a traditional open loop system, what we do is we have from the hydraulic tank, we have a line pickup which goes up to the pump, and then from the pump we go out to our actuator. In this case I'm going to go to a hydraulic motor, and then from the motor that oil will return straight back down to the hydraulic tank. And that's what we can see with this particular unit that I've built here. I've got my hydraulic pump which is mounted down the bottom here. The oil from it will come up through this hose around to my hydraulic motor. It goes into the motor, activates it, comes back out through this port, back around and into the hydraulic tank. Now if I start this up, I would expect to see the pump oil flow come through and start turning that wheel. And we can see that that's now happening. So my path of oil in my loop comes from the tank, sucked into the pump, pushed out through the motor and back into the hydraulic tank. And at the moment we look at it and all the oil from the pump is going through the wheel, so I don't actually have any control over that oil. So what I have to do in an open loop system is I actually have to install additional valving in order to control things. So for a start what we're going to do is we're going to put in a directional control for if I want to turn the motor in the opposite direction. So what I would have to do is I would have to actually cut the line here, remove those hoses, and I install a valve in here. I run from my pump into the valve, from the valve to one side of the motor and the other side of the motor, and then this side goes back in to the hydraulic tank. And I'm then with this valve, which I'm going to put a little lever on it, I'm able to change direction of the wheel. So I'm going to do that here now. I'll stop my pump, I'll isolate it so that I'm nice and safe, test my isolation, and then I'm going to take the hose from the outlet of my pump, I'm going to remove it from the motor, and I'm going to install it into this directional control valve that I've got set up here, into the P port. I'm then going to take the hose here, which we can see returns into the hydraulic tank. I'm going to remove it from the motor, and I'm going to install it into the other side of my directional control valve. And now my directional control valve, what I've done is I've connected these two hoses. From the pump is connected into the valve, and the return from the valve is connected to the tank. All I need to connect now are the top two hoses which go to the motor. And these are called our A and our B working lines when we talk about them in reference from the valve. And that's it. I've now connected my hydraulic directional control valve into my open loop system. I'll remove my isolation and we'll give a demonstration. So the first difference is now when I've started it, it's not moving. And I can then grab the lever of my directional control valve and push it one way. The motor spins in one direction. And if I pull the lever, you can see the motor will actually change direction. And I can therefore change the direction of that motor. The next thing I might want to do in a hydraulic system, an open loop system, is I might want to actually limit the amount of oil which goes into this motor so that I can control its speed. And one way that I can do that is to install a flow control coming out of the pump. And what that effectively does is it closes down the size of the hose, or the size of the fitting. It makes a restriction which limits the amount of oil that can get through. And I've actually got this already installed in my system here. And you can see that if I activate my valve, my motor will spin at a certain speed, and I can then actually start to close off the flow control valve, and it will actually slow down the hydraulic motor, and in turn slow down the wheel. You can hear when it does that the pump is starting to load up, and my system is starting to create a lot of noise and also a lot of heat. The reason for this is that any oil that doesn't come through here actually has to go somewhere else. And in this particular system, an open loop system, they'll generally go over a relief valve, or it may be a compensated system, but we'll talk about that at another time. But in this case, to speed up the motor again, I need to open the flow control, and I take away all that restriction in my system. So in the basics of an open loop system, I have a tank from which I draw oil into a pump. I push it off into a system which goes to flow controls and directional controls. Those flow controls and direction controls determine how fast and what direction the actuators will move. In this case, a motor will spin. And that's how I achieve open loop control. When the oil from the pump has gone and done its job at the cylinder or the motor, it will return back into the hydraulic tank where it can cool, settle, and be ready to go back into the suction. And my loop involves going through pump, motor, tank as it goes through. Let's consider now what we call closed loop systems. Because a closed loop system is slightly different. I still have a pump, I still have a motor, but instead of the oil, and I still have, the pump outlet going up and into the motor, but instead of the oil that returns out of the motor going back into the tank, what I do now is I actually run it straight back around and back into the pump again. And this is what we call our closed loop. We're going from the pump into the motor, back into the pump again without returning to the hydraulic tank. In its simplest form, that's the main principle behind a closed loop system. And I've got one built here. My closed loop pump is this blue unit up here. This is one side of the port, and this is one port, and this is the other port. My A and B ports coming out of my pump, and as you can see, I've got two hoses. Both hoses go across and end up entering into my hydraulic motor, which is going to turn my wheel. If I start my pump up now, you can see my wheel isn't spinning. And the reason for this is because the pump is different to my open loop pump. With this pump, I've actually got control of the pump at the pump itself. And I can push the pump in one direction, which causes the wheel to spin one way, and then I can pull the pump back the other direction, which sends the wheel in the opposite direction. Now this lever here is directly linked to the pump's swash plate. And if you've ever seen inside a piston pump, it's made up of a barrel, a series of pistons, and a thing called a swash plate. The swash plate can sit at various angles, and depending on the angle of the swash plate will determine the displacement of the pistons. The more the pistons are displaced, the longer the stroke on them as they go around, the more oil they will push into the system. So if I have a lever connected up to this swash plate, what I'm doing when I push that lever back and forward is I'm actually directly pushing the swash plate into different positions. Hence, the further I push the angle, the more oil I get out of my pump and the faster the wheel turns. If I push it just a small amount, I will get just a small amount of oil, and my wheel will turn very slowly. If I push it further, I increase the displacement of those pistons, and I can increase the speed that my motor spins at. If I pull it back into neutral, where my pistons are now not stroking at all, the pump itself is still spinning, but there is no oil going through the system. So a closed loop system is very efficient because the pump replaces our previous directional control valve and our previous flow control valve, giving me a much more efficient and much more direct flow path for the oil to travel in.